name is Abhishek Nandy. I am Intel Blackwell developer as well as Intel software innovator. And my role is on, I'm an application architect, AI and IoT. So this particular session that I would be talking upon would be on the swarm optimization. So what's so good about swarming? It can be considered as a group of objects working together. As you see from this particular figure itself, you see that there are a lot of group of fishes coming together to complete a particular goal. So they are working together as a unit to try to achieve some kind of function. The swarming is an idea where a lot of things like objects, living beings, or complex programs work together to reach a particular solution. So in this particular figure also you see all the details. Now if we just move away and just think about swarm intelligence. When we are talking in terms of intelligence, that means we are talking in terms of taking some kind of decisions. So swarm intelligence is an important part in artificial intelligence. Swarm intelligence is known as collective behavior of decentralized, self-organized system, natural or artificial. That means if we just focus on this particular word, swarm intelligence, if we want to apply it in the field of computer science, we have to design some programs. These programs should be taken help from such programming languages such as Python, C#, or other programming languages too. And we just go through the behavior of this flocking of birds or flocking of the fishes to get a concept that we can work together, or we can work on a program that work together to reach this goal. So the key definition or the key words that we need to focus on is the collective behavior of the decentralized, self-organized system. That means they work together to try to reach a goal. That might be natural or artificial. In today's world, we see a lot of changes, like armies implementing a group of fleet of drones which work together to do some kind of changes. Like if you are moving around, we are trying to do some kind of activity, some kind of operations at a particular place. They go together and try to find a solution. So that's an example. And apart from that, it can also be used when there are places like firefighters working towards solving or reducing the fire at a place. This particular group of drones can take some kind of water, split it over as a group, and then can work together with the firefighters too. The swarm intelligence works like this. Now, swarm intelligence consists of a population of simple agents. What are agents? When you're talking in terms of agents, we are moving into a field of machine learning called reinforcement learning. So artificial intelligence, when it evolved, it changed from artificial intelligence as a broader sense to machine learning. So machine learning, when the data was going at a faster pace, it changes from machine learning to deep learning. Now, another branch of science or machine learning has come up right now, which is known as reinforcement learning, where the focus is more on the state that it is in, the action it needs to take, and the rewards it gets when it reaches to the next state. So there is one kind of decision that is required from moving from one place to another. So when we are implementing this kind of concept with the help of agents or software programs, agents are known as software programs that help us to reach these places. So swarm intelligence consists of typically of a population of simple agents or boids interacting locally with one another and with their environment. Okay, now when you're talking in terms of swarm intelligence, as we see from this particular figure, are a population of agents and boids. So how does they interact? How do they interact with each other? When you're talking in terms of reinforcement learning, the total work is dependent on the type of environment. So when we're talking in terms of machine learning is worked on data set. Reinforcement learning works on environment. That environment might be local, that might be known to us, or might not be known to us. So we have to find out which way our solution works, and we can work together to find both the path. Is it local or is it environmental wise? Now, applications of swarm intelligence. So if we just talk about swarm intelligence, there might be a lot of things that are working, like ant-based routing, crowd simulation, swarm grammars, human swarming, or swarming art. These are the type of applications that are there in the swarm intelligence. So if we just move along, first of all, we'll touch upon ant-based routing. So what exactly is ant-based routing? It is based upon networking concepts. So when we are dealing with something as similar to telecommunication networks, we are dealing with ant-based routing. The idea of ant-based routing is based on reinforcement learning, as there is a lot of traversal of paths, forward and backward. So when you're talking in terms of like moving from one place to another, a decision needs to be made from one state to another. So which state we want to jump in next is being very decisive, and it should be correct too. So when it is being involved, this kind of concept, when it is applied in terms of networking tool, we say it as ant packet. And also when they work together, they flood the entire network. Okay. So now crowd simulation. We have seen a lot of movies, like when you're talking in terms of, say, movies like Batman Returns. It was one of the super hit movies of 1992, where this entire simulation of the penguins that was happening in the last moment of the movie, it was done with the help of computer graphics. So when computer graphics is applied to get a particular solution, we also use it in terms of crowd simulation. At movies, when crowd simulation is done with the help of computer graphics, we call it swarm optimization tool. Now, human swarming. This is just an evolving concept and is gaining very popular. It is getting popular day by day. Because in this particular human swarming concept, what we are doing is, there might be lot of minds. So when a lot of minds work together for a complex solution, the solution that we get for that particular problem is a unique one. So human swarming is based on a collective usage of different minds to predict an answer when all of the brains of different human beings act together, getting a particular solution, which can be a complex problem. Using collective brains in the form of human swarming results in accurate results, as we have discussed. Now, swarm grammars. There may be a particular characteristic which acts as a different swarms working together to get varied results that are similar to art as well as architecture. So if you are talking in terms of art and there is an architecture, there is a common word. There might be a common word that is unique to art as well as architecture. When you are trying to bring in those convergence of art as well as architecture together, we consider that as swarm grammars. Now, swarm art, swarmic art. Swarmic art is combining different characteristics of swarm behaviors between different species of birds, fishes. Gives a swarming art. That means we are getting a particular picture that we have already shown in the first page of fishes. That is a swarming art. So this kind of characteristic, when captured in the artistic format, is called swarming art. So Rastrigen function. When we are dealing with swarming, this particular function, which is known as Rastrigen function, is a basis for optimization problem. As it is being mentioned, it is a function which is non-convex and is used for optimization problem. So why we call it non-convex? Non-convex may have multiple feasible regions and multiple locally optimal points within each region. So if the local minima for this particular function is passed, and we can change accordingly. So if we just focus it and have it in a figurative format, we have it like this. So Rastrigen function is a non-convex function. It is specifically used for performance test problem. There are a lot of optimization scenario that can be created, and the figure that is resulted is somewhat like that. we can have different kind of patterns. The undulations you see is a type of changes that is happening due to this rasterization function. So before going to that, what we would do is that, as programming the entire concept would be a bit difficult, I would run through a video that shows the entire concept of rasterization function in place with the help of Python language. So let us just go through and watch the video that I have created, say, half an hour ago.
So our names for this particular environment is TensorFlow GPU. It will just take me in. Take some time so let us just get started. First of all, we'll input general for mathematical functions to say graphs. Now we'll use also the MPL toolkits for getting to see the function in an appropriate image. So we are doing that. We'll be importing the math function to do the type of calculations we are doing. We'll do that here. Now after that, we'll use the matplotlib pyplot. So it's also done. And now we will import NumPy. NumPy is one of the distribution of machine learning package that is generally used for doing calculations for machine learning as well as mathematical calculations too. Now we will define a function. This function is the rasterization function that we will talk in the next section, or we'll show the function that is being made. So rasterization is one of the functions which is non-convex, that is we have already discussed that it comes in a different shape, and it's very useful for doing optimization, especially for swarm optimizations too. It's very useful. So now what we are doing is that we are declaring to for the graph that we are creating, or the rasterization function graph that we are plotting, we would declare two variables, one x and y, for the linear space. So it's being created right now. Now we'll create a mesh grid for both x and the y axis that we have created. The mesh grid is created. Now we will be utilizing the rasterization. We'll do the projection.
So finally, this particular option, that is axfix.gsa, does our 3D projection, and we would be plotting it to a particular place and finally saving it as a PNG or a PNG file that's being there. So let us just run through it faster.
This error because there was another word. I will plot this as a function and save it.
So this particular PNG file gets saved to your computer, and we just run it.
We created this. So the rasterization function plot has been created. Now we'll just see it over here. If you just open up in photos, so that's the function that we have.
So with the help of it, like, we have created this function. So this is the basis for forming the swarm optimization, and after that we would be talking more on different programming languages too. So let us just start working on the same place where we were working, like the presentation that I was showing in. So swarm intelligence in Python, the thing we have done, we can also implement the same thing using something, a distribution from Python known as PiSwarm. PiSwarm is available at this particular place. This is a research toolkit specially available for doing our swarming calculation. So we can get PiSwarm from this particular place, that is python.org PiSwarm. So when we just reach this particular page, it would land up to this web page where you get all the details. You can directly download it if you are working on, or you can also have the Anaconda package installed where you are working on the environment. So PiSwarm is very useful because you can do different kind of utilizations, like local optimization for your swarming, as well as changes to your swarming, that is local as well as global. Okay, so PiSwarm is essentially a good tool to implement optimization algorithms with PSO, that is particle swarm optimization, for star topology as well as ring topology. The difference between star topology is that in a star topology, there is a centralized point with sources to different objects connected together as a star format. A ring topology, each and every individual is connected. So it's like the star, for the star, the source of giving information is a centralized point, but ring, everybody is sharing the information on its own. So installing PiSwarm, we get inside the terminal and activate the Anaconda environment. If you're working on an Anaconda environment, we have to get inside that. Then we have to just activate it, such as source activate universe. And the dependencies needed for the PiSwarm is NumPy, that's also a machine learning library, SciPy, as well as matplotlib. So after that, we have to install the PiSwarm, that is pip install. When we go using the pip install, we use the PiSwarm and it gets installed. The process gets completed. So PiSwarm is also very useful when we are doing some kind of localization for different kind of functions, or we are trying to achieve some kind of simulations. So in this case also, if we just go through the video that I would be showing right now, if you face some difficulty.
In this video, we'll see how PiSwarm is implemented using Python to just with a particular name that we can use.
So this particular video, let me just go through the questions that are there.
Now we'll declare a dictionary and some details. After that, we'll optimize using global best PS. We will do this example with the help with global best PSO and local best PSO.
So first of all, we have declared a dictionary where it contains, we have named it as options, and we would be applying the PiSwarm concept in localized as well as global environment.
So we have to initialize the optimizer.
So first of all, we are initializing the optimizer, and we are calling in global best PSO for doing our optimization on the dictionary that we have created.
Optimizer has been initialized. Now after that, we would be using the verbose component. We would be using printing some steps at times. So if this iteration steps, if you reduce also, it would work. And verbose is like, as mentioned, using verbose argument, we can build the verbosity of the argument using print step to count after a certain number of steps. So after three steps, this verbose will be counted. So let us just check on this. You see, iteration is already done and it has finished. And after certain steps, you see the iterations. Okay. So it goes through 1,000 iterations for, as we have mentioned over here. Now, as we have done global best PSO, let's take a look at also the local best PSO. So we will do the same thing. First of all, we'll create a dictionary. Then we optimize, we create the instance of the optimizer. And in the next step, what we would do is that say we would do the verbose after 5 steps and increase the iteration value to say 3500, and the print step is say 70. So let us just do it. So
that's like that the type of simulations you can do, but we have just touched upon the simulations that are like what we can say is console oriented. But right now this simulation that I would be showing would be on a programming language called processing, and it's very useful. It's an open source language, and the type of usefulness for this particular utility is huge. Just let's go through the video first. So this particular video, what we are doing, we have used the processing 3.1 currently, and for that, like when we are implementing the agents or the voids, we will create an array for this particular voids where there would be number of voids that would be targeting to a point, or the mouse pointer that we are taking, we are moving around would be our the type of target that we are trying to implement. So if we just run through it, what it would do is that probably for the first time, as we check on this, like it would create 10 voids that would be targeting towards the mouse pointers. So let's just go through it.
And two of the voids, and at a point to a particular point, the swarms that are created will target to that point. It is a similar behavior, and swarming, as we know, is very useful in terms of doing a job faster with a group of people, or say group of objects working together. That might be an agent in terms of reinforcement learning too. So let us just go through the description and see what happens exactly in the program. And we have taken help from one of the open source code that was there and updated it according to our liking. So let us just run this particular program. So when we are running it, we see that this particular point that is over here is like a swarming point. So the swarms are coming in. If I take it around, I would try to target this point. Whenever I am taking this point anywhere in this particular screen, mouse, I'm using it to mouse to move it around. So the swarm is being changed right now. Okay. So we can see the generate that right now 10 particular voids are trying to point to the target in the screen. This is the mouse. If you're taking it, so let us just take it to this particular point. What it does. It also tries to work along with the swarm. So let us see if we increase the size of the voids, will this program work on it? So let us do that experiment. So for increasing the size of the voids, the point where we have to target in the code is this particular array list. So if we just increase the number of voids to say, how likely if we say 100, so that would create the same swarm behavior for us. Will it or will it? We'll have to check it. So that is the idea. And so the void class void function will say that the void is of a particular element, or we can say that where it intend to go. So that is the usage of void. Let's just run the program once again. And we see that now 100 voids are trying to target that particular point. So this particular behavior is very much working with an example from processing, and it's very useful.
So we have gone through the example of processing 2. Right now, this particular video, the final video or the final conclusion of swarming behavior, we would be implementing it currently on Unity, because currently for each and every person, Unity is the tool that everybody is looking into. So the swarming behavior of Unity can be best realized with the newest version of Unity, that is the 2017 version, and it has some examples that are very useful for us. Like if we just target this particular option, I am just opening it up.
Hello. In this example, we will check on what.
Okay, so let me just open up Unity. This particular version of Unity is the latest version of Unity that we have, and what we have done is that we have used assets. Like this particular assets is the atom ball assets we have, and over this particular atom ball, when it is moving around, a swarm would be created across, and this particular effect that is being realized is done with the help of a heavy graphics, and we have implemented shaders too in this. So let us just go through the video now. So this camera, this is a camera that is doing the job for us. When it is revolving through the object, or when it is trying to capture the object, the effect would be shown as the camera moves.
Simulations for Unity, we have used one asset from I have used. You go to asset store.
So the assets that I've used is very easily available, and it's free of cost. It's an open source assets from asset store.
Particularly if we just move down, this particular package, that is ball pack package, we have used in this demo. Okay, now if we just go to the scene, and if we just click on play, there is one thing in it. There is this swarm that is being generated for this particular pattern, and it would be somewhat of a crawling from a swarm that is being generated in this particular atom ball. So if we just click on run right now, we see that the swarm is being generated for this particular atom ball. So this is one of the examples like how swarming actually works, and it is trying to gather momentum. And if you just click on the scene option right now, it shows how the swarm is being generated. Let's also check on one of other examples that are there. We go to the assets option. We will go to track. Then we just go through all the details that are there. So if you just click on this particular thing, swarm, we will give all the examples, the scripts that are involved. It is totally free. And when we just click on this test, there are 3 options available. So if we just click on this particular thing, the demos, and now if we just click on run, what it would do is that it would create the swarm over this skull. So if we just focus on this particular skull, and this is the camera involved. So this is the camera preview. So if we run this particular simulation, so we see that the swarm is being generated on the skull against the skull. So this is how another swarming simulation also occurs for this particular option. And there are a lot of opportunities when you are dealing with swarming. Because swarming is a complex action that is happening. So you can take advantage of this freely available assets. Unity, you can also develop some other simulations too. So that was all about a small swarming demo, and we have covered it in 3 languages, programming languages, one in processing, one in Unity, and the other that will be shown in Python.
Okay, so If you have questions, you can ask right now. So operational situations like when you're talking in terms of solving a particular problem, apart from games, we can reach or we can get this kind of work done with different Internet of Thing devices also. So now the concept of Internet of Things is changing. It's being integrated with artificial intelligence. So what we can do is that as Intel provides lot of resources like NUCs. NUC works as a resource for doing a particular source. And if we say that that is like when you're talking in terms of a star topology as the main brain source of working together. So if you're trying to uh, a job that has been given to 7 different objects or 7 different robots. So 7 different robots, when they are working simultaneously to do a job that is easier or trying to solve a problem that is that needs lesser time to do, we can implement it in apart from games. In conditions also such as army operations, we use drones. So when we are using drones, when drones are working together as a fleet, that is also useful. So when we are working as a swarm of drones are working together to move from one place to another at places where the combat situations are not feasible for soldiers to go, they can check on different places like is it can we do some operations over there. They can take pictures, they can say operate some with weapons to destroy some targeted points using this kind of concepts. Not only does it works with army operations, when you're talking in terms of agile environment, when there is a program that is being run at 50 different places to do a job, if it works together simultaneously to achieve a goal, then we can also implement swarming on that. So swarming has different kind of conceptual importance that we can use to, and it is also gaining popularity day by day as we can see the changes. So any questions apart from that? And apart from that, also we are working on a book on reinforcement learning that covers the entire swarming optimization. So that book is also written with my my fellow innovator. She would be taking a session tomorrow on tactical decision making. So you can go through the book. It covers a lot of concept, and it is particularly enriched with different examples of swarming. No, it's already being implemented. So if we just take an example, I am opening up human swarming. Human swarming is already being implemented, and there are companies like working together. There is an AI based company already has a solution for it. So human swarming is based upon like chatbots. If they are trying to be, if it's like one dimensional, we can integrate different kind of chatbots together with the human intervention to make the collective application together more. So human swarming is happening, and it's also like if we just check on human swarming as practicability, there is one AI based company, they are already working on this. So let me just go through the details. Went to the same page, so you can also check on it. I would give you the exact information like which companies or which are the type of thing. Okay, let me just share you the link. This is the book that would be published in December. We have done the work for it with all the details. You can just have a look on it.